Okay, so starting video number 2, we have the graph of the exponential function f of x equals z to the x is shown below. So the original function graphed here is an exponential function, and use it to evaluate log base z of 4. Log base z of 4. So when I look at this, one thing that sticks out is I don't know the base, but what matters is that I know the base of the exponential function and the logarithmic function are the same. So this tells me that these are inverses as they're written. Okay, these are the inverses as they're written. And what do I know about inverses? That the x and y values switch. So when I look at this, normally in parentheses from my argument, I would have an x value. But if I'm looking at the graph of the inverse, so I'm going from the log back to the exponential function, this is going to be a y value that I'm looking for. So I come here to 4 and get that the x value that it produces is -2. Then for the next section, for each of the following function pairs, use function composition, that's an important part, to prove whether they are inverses or not. And look, provide a sentence that explains your reasoning. You won't get full credit without an explanation. You won't get full credit without an explanation. So when I look at this then, I'm going to have to, remember you have to prove composition both ways. Both ways. Okay? You have to prove that it works both ways. If it fails one way, then it doesn't work both ways, so you can stop there. So I'll show you what I mean in a second. So the first, I'm going to do f of g of x. So I'm going to write f of x first. So I'm going to have log base 4 of 7 times something plus 3. And in there, I'm going to put g of x. So I'm putting, that's where the x was, and I'm putting this in here. I'm going to put g of x in here. So 4 to the x minus 3 over 7. And now let's slowly start canceling stuff out. I've got 7 and I've got divided by 7, so this can cancel out, and I have log base 4 of 4 to the x minus 3 plus 3. I have log base 4 and 4 as a base, so these would cancel out, and the x minus 3 comes down, and then I'm left with x. So f of g of x yields x. That's good. Let's check the other way now. I've got g of f of x. So I've got 4 to the log, so in parentheses, log base 4 of 7x plus 3 minus 3. And this is all over 7. Now this one looks goofy, I ain't gonna lie. This looks a little goofy. But making sure I wrote everything down right here. Okay. Now, one thing I see here is before I do anything, this plus 3 is not attached to the log itself. It's not part of the argument, so I can go ahead and cancel out these. So I'm left with 4 to the log 4 7x over 7. Base 4 and log base 4 cancel out, and I'm left with 7x over 7 equals x. Okay, so it yields x both ways. So for this sentence part of this, which is really important, I would say f of x and g of x are inverses because function composition both ways yields x. And that's just a fancy math way to say if I plug them into each other both ways, f of g of x and g of f of x, they both yield x, which means that they completely cancel each other out. That's why that's the answer. Now for 21, let's do that again. So I've got m of x and n of x. So I'm going to do m of n of x. And I've got the square root of parenthesis to plug g of x in, plus 3, and then minus 4 outside. And inside parenthesis, I'm going to put n of x. I've got x plus 4 squared plus 3. Okay? And I don't really need these parentheses if that helps you think about it. So right here, I've got x plus 4 squared, combine the 3's, and I've got plus 6 minus 4. And notice that these 3's right here did not go away. So there's really nothing I can cancel out from here. There's nothing I can do to make this any simpler. I can't just go straight to taking the square root and canceling out this. I can't do that right there. I might be tempted to. Even if it did, it still wouldn't work out. Like I would still have x plus 4 minus 4. That cancels out. And I would still have x plus 6. So right here, there's nothing I can do to cancel it out. So I'm done right there. I know one way fails already. So I can just say because function composition does not yield x, the functions are not inverses. Okay, so the big key there is if you plug them into each other, it should completely cancel out and you should be left with x. Last page, find the inverses of the function below. If necessary, state the domain restriction. So remember, the two domain restrictions. So domain restrictions are when you have a fraction, denominator can't equal 0, and then for if you have a square root, it has to be greater than or equal to 0. Whatever's inside the square root has to be greater than or equal to 0 because you can have a negative in there. So let's look at this. So there's no domain restrictions as the function currently is. It doesn't have a square root or a fraction. So I'm just going to go ahead and find the inverse. So I'm going to write it as y, switch x and y. Then do the algebra to isolate y. Take the square root on both sides. And then add 3. Y is isolated now, so I would rewrite this as, because this is k and not f, I'm going to rewrite this as k to the negative 1 of x. The inverse of k is equal to the square root of x plus 9 plus 3. So that's the inverse. That's step 1. But now look at what pops up. A square root. So I know I have a domain restriction. So for the domain restriction, whatever is in the square root. I don't have to worry about the plus 3. I'm only worried about what's in the square root. So I could say that x plus 9 has to be greater than or equal to 0. It has to be 0 or above. So that gives me x is greater than or equal to 9. I would take this right here. And if you wanted to write it in interval notation, you could also say negative 9 to infinity. Either way, I'll take both. Yep. Okay. Now, let me erase this here. Just a fuzz so I can see. It says p of x equals 9 log base 11 of x plus 8. So I'm going to find the inverse. With log and exponentials, I don't have to worry about a domain restriction for now. Like, I'm not going to make you worry about the domain restriction for now. So just worry about fractions and square roots for now. We can talk more about domain restrictions with logs in the future. But for now, just worry about those two. So I'm going to write y equals 9 log base 11 x plus 8, switch x and y. Okay, first thing I'm going to do is isolate the log. So divide by 9 on both sides. I have x over 9 equals log base 11, y plus 8. Now to undo the log function, remember what I do is take the same base on both sides. So I do 11 as the base. So on the left side, I'll end up with 11 to the x over 9 equals. This cancels out and the argument comes out, y plus 8. If I minus 8 on both sides, I end up with 11x over to the x over 9 in the exponent, and then I'm going to have minus 8 equals y. So to rewrite this, remember this is p, my function p, so p to the negative 1, the inverse of p is 11 to the x over 9 minus 8. 2 more. So here I've got rewrite, boom, rewrite and switch. So I'm trying to get y by itself, but it's in the denominator, so I need to multiply the entire denominator over. Okay. So I'm left with 7 y minus 5 x equals 12. And you can go ahead and distribute here, but it'll honestly make life a little bit harder. What I would go ahead and do here is leave it as is. Let me think. I would leave it as is, and here just go ahead and divide the x over instead of multiplying it in. Yeah, I was trying to think if that's the way that I would want you to do it. Sorry, give me 1 second. Actually, no, that'll be more confusing, sorry. Let's go ahead and do it like we have been doing it. Let's go ahead and distribute, because that's what you're used to. So 7xy minus 5x. So now I've got this isolated, where I've got it to the left side. Now I can add the 5x over, so I have 7xy equals, add the 5x on both sides, 5x plus 12. Yeah, that'll be easier. There's multiple ways you can approach this problem. I pause like mid-thought there to make sure that I'm explaining it in a consistent way. So now to get y by itself, I can divide by 7x. And then that's going to give me that cancels out, and I've got y equals 5x plus 12 over 7x. Okay. And then rewrite the q. So q to the negative 1. X. 5x plus 12 over 7x. Alrighty. And the last one here, we've got (14) to the x over 3 minus 13. So let's rewrite this. I've got y equals this. And I'm going to switch x and y. I'm going to add the 13 over first. And then I'm going to be able to get the 14 to go away and free the y there, I'm going to do log base 14 on both sides, because the bases here match up, and so they cancel out. So I've got log base 14. I like to put my argument in parentheses here. I think it's always easier to do it that way. And then y over 3, isolate that, times 3. So that ends me with 3 log 14, base 14 of x plus 13 equals y. And for now, we'll just leave it in this form. We're not going to worry about doing any of the crazy rules that you would have to do to rewrite this. Let's just leave it there. So we've got r, so I'm going to have r to the -1 of x equals 3 log base 14 of x plus 13.